All right, Algebra 1, here we go. Last set of notes for Chapter 1. And what we are doing today is simplifying square roots where we have some variables in it. And we're also going to be throwing in not only square roots, but third roots and fourth roots. So we're going to start off by reviewing our simplifying square roots. So I know this was something that a couple people were getting a little bit confused on, so let's review this. So first of all, we want to do our factor tree. So pick a number that will divide into 108. Again, your factor tree could be a little bit different than this. You could start off with 2, you could start off with 9, you could start off with 3. You could have something different than mine, but our final answer should still be the same. So I started off with 4 and 27. So 4 we can break down into 2 and 2. 27 is 9 and 3. And then 9 we could do 3 and 3. And again, we're looking for a pair. So I have a pair of 2's. That pair comes out as a 2. And then I got a pair of 3's. You could take these 2 3's or you could take these 2 3's. Doesn't make a difference. For every pair, we take 1 out. And then this 3 did not have a pair, so that 3 stays underneath the square root. And the last thing we got to do is multiply these two numbers on the outside. 2 times 3 is 6. So that is your final answer there, 6 times the square root of 3. All right, so what is different from today in comparison to those problems is we now are throwing some variables in here, okay? So it doesn't make it a whole lot different. We're going to start it off the same way. I'm going to say 45, break it apart into two numbers. So I know I have 45 is 5 and 9. 5 I can't do anything with, but 9 is 3 and 3. All right, I haven't done anything new yet. This is all review. So far it's all review, okay? 9 is 3 and 3. I have a pair of 3's, so that comes out as a 3. 5 stays underneath. Now I'm going to leave a little gap here because I do have something else that is changing here. I'm not completely doing everything the same. There is something that's a little different. So I'm going to leave a little space here. The 5 stays underneath. Now what's different is we have this extra term here, a to the 5th. Now what that means is we had 5 copies of a being multiplied. So what that means as far as simplifying a square root is some of these will come out. Now, we had 2 3's being multiplied together, and that came out as a single 3. So this means we have 5 a's. 1, 2, 3, 4, 5. And it's the same thing. For every pair of 2's, 1 will come out. So what I suggest you do is we're going to list these a's, and we're going to list them 2 at a time. We're going to list 5 of them, and we're going to list them 2 at a time. So there's 1, 2, 3, 4, 5. And then for every pair, 1 comes out. So there's 1, 2 pairs. So there's 2 a's that will come out. So 1, 2 a's come out. And then this guy right here didn't have a pair, so he's going to stay underneath the square root with the 5. Now, from our exponent rules that we just finished, this is a to the first, this is a to the first. And what do I do with those? If I have a to the first times a to the first, what do I do? Well, I'm going to add them. 1 plus 1 is 2. Square root of 5a. So there is your final answer, completely simplified. 3a squared times the square root of 5a. Okay, so it's not a whole lot of extra work, but there's a couple extra things that we need to do with our variables. Okay, so the numbers are exactly the same. It's just the variables that have a little bit of extra work. All right, so let's take a look at this one here. Now I have it all done, so just follow along with me while I explain what I did. The number, again, same thing that we did before. 27 is 9 times 3. Nothing different there. 9 is 3 times 3. I had a pair of 3's. So that 3 came out. That was this 3 here. Let me change the color. So this pair of 3's came out. That was this 3 right here. This 3 right here did not have a pair, so that stayed underneath. That was this 3. Then I had 7 p's. So I wrote them 2 at a time. So 1, 2, 3, 4, 5, 6, 7 p's. And then I started circling them 2 at a time. So there's 1 pair, 2 pairs, 3 pairs. So that means I had 3 p's. Now, the shortcut way of doing this, instead of writing p times p times p, however many pairs you have, that's your exponent. So there's 3 pairs, so I have p to the third. Okay? So again, that's going to be p times p times p, which is the same thing as p to the third power. So I just jumped right to that right here, p to the third power. Okay? N to the second means I had 2 copies of n, which means I had 1 pair, and I brought that out as 1n. Remember, for every pair, I bring out 1 copy. Oh, sorry, I got ahead of myself there. I had 1 p left over, and that p stayed underneath. Sorry, I got a little bit ahead of myself there. Okay? So there's B. C. Now, I just did the work here. I didn't write my answer. I just did the work for C. So let's do the final part here. Now, if you notice, the difference here for C is I have something extra out front. We did problems like this, so this is nothing new. We've already done stuff like this. So I started off with my factor tree, 60. I use 6 and 10. You can do 5 and 12, 2 and 20, 3 and 2 and 30, 3 and 20. I use 6 and 10. 6 is 2 and 3. 10 is 2 and 5. I got a pair of 2s. All right, so I know I'm going to take a 2 out. I have a 3 that stays underneath, and I have a 5 that stays underneath. A to the 7th, I mean I had 7 A's, so 1, 2, 3, 4, 5, 6, 7 A's. So I have 1 pair, 2 pairs, 3 pairs, and then 1 A left underneath. So everything circled comes out as 1, and everything underneath will stay underneath. Or everything underlined will stay underneath. Except for this that I have underlined right here. Let's get rid of that. All right, so now let's rewrite this. So I had the negative 2A out front that was out front in the problem, right? That stays out front. These 2's that I have circled will come out. So times, we're going to bring that out front. And then this right here, 1, 2, 3, I had 3 A's that came out front. If you want to write that as A times A times A, you can, right? We can write A times A times A if you want. Or you can, if you know that that's A to the third power, you can just write A to the third power. That's fine. Square root, put the numbers first, so 3 times 5. And then your variable second, we only had 1 A left. Okay, now this is a mess. We need to clean this up. This is just a giant mess right here. We need to fix that. Do your numbers first. Negative 2 times 2 is negative 4. And then how many A's do we have? 1, 2, 3, 4. So that means we have A to the 4th power. If we add all those exponents, it'd be 1, 1, 1, 1. Add those ones up, we get A to the 4th. Square root, 3 times 5 gives us 15. And then we have an A left underneath. So there is your final answer for that example, okay? Now, these last ones, we're going to go through them together because they can be a little bit tricky, a little confusing, but it's the same idea, same concept. If you remember, these are square roots, okay? Square roots, we were always looking for pairs. So let me jump ahead here and I'm going to come back. So do you see this right here? This is something that is not visible on these other problems, okay? So there's a 3 here. Well, look back here. There's no number here. If there's no number here, it's understood that it's a 2 because it was a square root, right? That's why whenever there was a pair, we brought one out because this is understood that there's a 2 here. Well, right here, there's a 3. So what do you think we're looking for? A set of 3, right? Because it's a third root. So we're looking for sets of 3 now. All right, so that's what we're going to try and find in these problems. We want to look for a set of 3. All right, but the process is exactly the same, okay? So we're going to do this the same way. We're going to start off, we're going to take 54, and we're going to do our factor tree. So 54 for a factor tree, I like 9 and 6. If you don't like 9 and 6, pick whatever you like, 2 and 27 or whatever, I don't care. All right, 9, we only have one option here. We got a 3 and a 3. 6, we only have one option. We got a 2 and a 3. Now, remember, for the other problems, we had square roots, so we looked for a pair. These are now third roots, so we need a triple. We need 3 of a kind to take a number out. So I need 3 of the same number in order to take that number out. That's the only difference with these type of problems here. So I have 3 3's, so that means I can take a 3 out. If I only have 2 of a number or 1 of a number, that has to stay underneath. Okay? All right, now, x's. I have x to the 7th. So what does that mean? It means I'm going to write out 7 x's, but instead of writing them 2 at a time, like I did over here, I wrote 2 a's at a time because it was a square root. I'm going to write them 3 at a time because this is a third root. So 1, 2, 3, 4, 5, 6, 7. So I have 1 set of 3, 1 triple, 2 set of 3, 2 triples, and then I have 1 left over. So I have 2 x's that are coming out because there are 2 triples. So 1, 2 triples, and then 1 left underneath. So I have my, now don't make the mistake of just writing a square root because it's not a square root, it's a third root, so make sure you got that little 3 inside there, nested inside there, so don't forget about that. I have a 2 left underneath, and then I also have this x that didn't have a triple left underneath. Alright, so I'm left with a 3, I have 2 x's, so x squared, and then cube root, so again squeeze that 3 inside there, nest it down in that root inside that radical, and there's your final answer. Okay? Oh, that was kind of weird there at the end. Alright, so there's your final answer. Okay? Now I know some of you are looking at that and you're thinking, I have no idea what's going on, so if you need to rewind that and watch it again, go ahead and do it. We have 2 more that we're going to do here, so if you're still a little confused, just hang on for these last 2 problems, and you may need to watch them again just to see what's happening, but just stick with us here for these last 2. I didn't want to do these ahead because I wanted to make sure that I went through all of these third and fourth root ones together with you so that you can see exactly what's happening here, okay? So just stick with me here with these. All right, now, f is a third root, but for this one, this is a fourth root, okay? So pay attention to this number right here. That tells you how many copies you need in order to take that number out, okay? So this is a fourth root, means we need 4 copies of the same number, all right? So we're going to start with 625. All right, now 625 is kind of a big number, but I do notice that it ends in 5, right? So 625, if we divide that by 5, so I say, I know it has to be divisible by 5, right? Because it ends in a 5. So if I divide by 5, that's 125. That's still kind of a big number, so I'm going to divide by 5 again. I'm going to put the 5 over here. So if I do 125 divided by 5, that's going to give me 25 again. Now I have a nice number to deal with. 25 is just 5 and 5. So this one actually worked out nice because I needed 4, look up here, 4 numbers that are the same to bring one out. Well, what do I have? 1, 2, 3, 4 copies of the same number. I have 4 5s. That means I can bring a 5 out. All right, so I don't have any numbers left over inside this root. So let's move on to the x's. I have 8 x's. How many am I writing at a time? I'm writing 4 at a time, so let's write them down. 1, 2, 3, 4, 5, 6, 7, 8. Stop. I have 8 x's. I wrote them out 4 at a time. So that means I can take 1 x out here, and I can take 1 x out here. So that means I'm taking 2 x's out. And now look at your y's. I have 12 y's. That's a lot of y's to write. So let's start writing. I need to write 12 of them. I'm going to write them 4 at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we're done. How many y's do I take out? Well, I got 1 here, I got 2 here, and I got 3 from this one. So I have 3 y's that are coming out. So 1, 2, 3. And after we're done simplifying everything here, there is nothing left underneath this radical. Okay, there were no numbers left, there's no x's left, there's no y's left. Okay, so there's no radical left, and what I'm left with here is 5x squared and then y to the third. And that is your final answer here. Okay, so there are no numbers or variables left underneath your radical. This is your final answer here for this one. Okay? So again, if you're not sure, rewind it and watch that one again. Okay, last problem here, okay? Last problem. We're going back to a third root, so now we need 3 of the same to take a number out, or a variable out. So let's start with 24. So 24, I'm going to do 6 and 4. So 6 is 2 and 3. And 4 is 2 and 2. Okay, so I have 3 copies of 2. So I know I can take a 2 out. And I know that I have a 3 left underneath. Alright, let's move on to the m's. I'm writing these 3 at a time because this is a third root. I'm writing them 3 at a time. So 1, 2, 3, 4 m's. I'm just going to write out all my variables right now. So x, I have 2 x's, and then I have 6 y's. 1, 2, 3, 4, 5, 6. So how many m's can I take out? For every 3, I can take 1 out. So there's 3 m's. I can take an m out. This m does not have a triple, so it stays underneath. And then when we look at our x's, well, I don't have a triple. I have 2 x's, but remember, you need 3 to take an x out. So these x's cannot come out. They have to stay underneath. And then for your y's, I have 1 triple here, so that comes out. And then I have another triple here, so that can come out. And then I have no more y's left underneath. Alright, so let's see, what do we have left underneath our radical? Let's put the third in there so we don't forget about it. Let's start with our numbers. I have a 3 left. Our variables, I have an m. And then I have 2 x's. Okay? Let's clean it up. 2 m. Y times y is y squared. Third root. Put that little 3 in there. And then 3 m. X times x is x squared. There we go. So there's your final answer for this one. And again, that is your final problem there, final example. And again, if you need to rewind and watch those again, do that. Make sure that you understand what's happening there. It is the same concept as your square roots. It's just third roots you need 3, fourth roots you need 4 in order to take something out of those radicals. So I know it can be a little confusing, but rewind them and just watch them again until you understand what's happening there. And if you're still not sure, just send me a private comment or an email and let me know, and I can try to help you out more.